Okay, so we can do one numerical problems. Okay, let us see some good numerical problems. It might be useful for you to clear the concept of electrostats. So we have this equation. We have a rod of length L. Having mass M, and it is hinged. This is, you can consider y-axis O and X, and so total length is L, and it hits at this origin. This is the middle point. So this length will be L by 2, and this length will be L by 2, and this along this length there is given positive charge distributed uniformly, and in this section negative charge is distributed uniformly, and rod has charge density lambda. So, and uniform electric field exists in this space along this direction. Now you want to find the time period of oscillation. Okay, this is your question. Okay, to find time period, what will we do? We can do, we can give a small angular displacement like this, theta. Well, okay, we can give a small angular displacement theta, and consider this small section having length dx. Now this has charge dq is lambda into dx, and electric field is along this direction. So force, you can say dF is equal to E into dq, E into lambda dx, and this is x. And since this is negative charge here, you can see, so again considered in a similar way dx, and this length is x, and now since it's negative charges, electrostatic force will in this direction. For two force we have found equal to force separated by some distance, so it will create the torque couple, and torque is nothing but force into r perpendicular distance, and this is your perpendicular distance, this is your perpendicular distance. So force we have E lambda dx, and this is x, and this is going to be x sine theta, and this will be in a similar way, this will be again this is theta, so x sine theta. So 2x sine theta. Well, can you find the direction of this couple? Do you have any idea? Okay, look. Electric field dF and dF. This force and this force to consider here, and this is the R perpendicular. You just see this. This is R, and cross this direction. So this is torque in this direction. You can say clockwise. So when you apply the torque, external torque, and make an angle theta with it, then it has a tendency to make an alignment with electric field direction, so that it can feel no torque. Okay, it has always a tendency to rotate along the electric field direction, so that it can make alignment. But due to inertia, it shoots away like this and try to oscillate like this. Okay, it will oscillate like this about this line. So we need to find the torque, and we will develop a differential equation of SHM. So this is our restoring torque. This is restoring in nature. Restoring torque. Well, now d tau, we can consider d tau actually. For integration of d tau is equal to total torque. Okay. Now we have tau is equal to E lambda 2 sine theta x dx, and this is 0 to L by 2. Okay, so now we have 2e lambda sine theta x square L square by 2 into half. This is going to cancel out. So we have now L square by 2, so this is going to L square by 4. So we have E lambda sine theta L square by 4. So this is our torque. Now inertia torque. Inertia torque. This is nothing but I into alpha, and alpha is equal to d2 theta by dt square. This is angular displacement. To differentiate it twice, you find the angular velocity. Now I, about this midpoint, it is ml square by 12. This is moment of inertia of the rod about the midpoint. And now d2 theta by dt square. You know that the restoring torque is you can see it in negative. Okay. Now you can balance the two equations through torque, and you develop a differential equation. And from the differential equation, we have enough information to find out the angular velocity. Let's do it. ml square by 12 d2t and d2 square, which is equal to minus E lambda sine theta L square by 4. Okay, and we can write here sine theta is equal to theta, sine theta is equal to theta, because theta is very small. So this is our differential equation. Now, you know the general equation of SHM is, this is general equation. Theta is angular displacement, omega square theta is equal to 0. Okay, so you can find, you can compare with this equation. We have d2 theta by dt square plus e lambda theta, sorry, L square by 4 theta by ml square by 12. This is 0. And this much L square is going to be cancelled. So omega square is equal to 3 e lambda by m. Okay, so we have angular velocity 3e lambda by m. Now time period we have 2 pi by omega, that is equal to 2 pi under root m 3e lambda. So this is our desired time period. So now answer is available to you. Well, I think it's over now. We can solve other problems. Now, this is a disk and this is point charge of negative. I mean to say it has negative magnitude. Fixed at center, and the mass of disk is m, and rest on rough horizontal plane. So from this point, center, at height h, we have a charge q of same magnitude, just placed vertical above. Okay, at a height h. Now, this will attract with the force F because the Coulomb attraction or electrostatic force, this is F. Now, you displace this slightly. Okay, you displaced it slightly. The center, x is very small, h is much larger than x. Just to make it clear picture, I have make it large enough in compare with h. But in real sense, h is much bigger than x. Okay, with some good clear picture, I have just done this to make understand in a better way. Okay, this is a negative charge here. So you see this line join, the force is F, just join the line, this is direction of force, and we have one, suppose this is theta. So you see the force in this direction, we have F sine theta. Well, so you displaced it slightly and there is a force developed, and this is, I can say, restoring in nature, because restore means a force try to bring it back to its original position. This force is responsible to hold it back, but due to inertia, it will shoots away and reached at this point another x. Amplitude will be same, and this is the force in this direction. This again theta, and then this way f sine theta in this position towards the equilibrium point. Well, we have just disturbed slightly. In either direction, you can do this. So f sine theta is nothing but a destroying force developed in this body. Now we need to find the time period. Okay, now we find time period of oscillation. So well, we have already found destroying force f sine theta. So and there's a friction. So this is theta, and suppose this point is, you can say P. Now torque, restoring torque at point P. Why we are considering point P? Because at this point friction will be present. Okay, so and friction force will pass to this point, then torque will be 0. Okay, due to the friction. So we have torque to P at point P. We have F sine theta into R. Now inertia torque is nothing but I into alpha, and to this point, about this point, I is nothing but mr square by 2 plus mr square. We understand this because this has weight of inertia mr square by 2, and using the parallel axis theorem, the distance is r, mr square. Okay, you understand this? Like I think d2 theta by dt square. You can see 1 will be negative. Now sine theta, okay. So we have 3 by 2 mr square d2 theta by dt square, and here can transfer negative to this point. Okay, it doesn't affect anything. You can apply negative sign at any side of the equation. Now we have just f. What will f? Q square by 4 pi epsilon naught, and this is the distance. Nothing but this distance is h square plus h square. This is d and this is b, and this will have to news. And r square is actually h square plus x square. And what about sine theta? What about sine theta? P by h. X by under root square plus x square. Now, well, okay, I'm here. This is angular displacement theta, and here we have linear displacement. Okay, so first let it write angular acceleration, and we know angular acceleration is have relation with linear acceleration by a by r. So we can write here a by r. Now this is linear, this is linear. Equation is good now, and I think okay with equations. Mr square q square by x 4 pi epsilon naught we have h square plus x square 3 by 2 minus 3 by 2 mr square by a by r. So we have q square by x 4 pi epsilon naught h cube equal to minus 3 by 2 mr square, say mr by a. Oh, sorry. This is the torque actually. This is the force. I don't know. I have just mistaken somewhere because I have just write. Oh yes. This is R. So I'm missing R here. Well, so R and here R is all vanishing. So we don't have any R actually here. So we don't have actually any R. Now that is A to minus omega square x. This is the differential equation. Acceleration is d2x by dt square plus omega square by x is equal to 0. X is displacement. Now we have, you can write like this. You can write now acceleration is equal to d2x by dt square. So anything except s is omega square. So we have omega is equal to q square by 2236 pi epsilon naught m h cube. Now, okay, now we can find the time period, 2 pi by omega. You can do this. So this will be your angular velocity and you can find time period from now. Okay, thank you. If I have done some mistake in calculation, then I will be sorry for that, but I think it is okay. Well, suppose in free space I have a rod. This is a thin rod carrying negative charge distributed. Negative charge is distributed along its length, and we have a ring like this, and rod is placed along the axis of the ring. Mass of rod is m and length is equal to 2r, where r is this radius of ring. Ring has charge q distributed uniformly. Okay. when you displace this slightly, okay, just displace it, dy, it will go upward, dy. Okay, so at this point force is negative charges, so electric field at downward, electric field upward, both I think 2 dy length will be considered here, because there is a push force from downward and there is a upward force also acting, because downward there is electric field and up in upward direction, and I think at here this point you can find also force, because this ring and it has a electric field in axial direction. So when you disturb it slightly, it will oscillate. Then find the time period of oscillation. This is your question, and you can solve this. Now, I have already told you that unbalanced force will be due to length 2 dy. Hence, unbalanced force is equal to dq into E. This length, I say dq let us define charge distribution as lambda. Then we have dq is equal to lambda into dy. So we have unbalanced force is equal to 2 lambda into dy, and we have this length is r, and this length is r from the center, because it has total length 2r. And 2 dy, the electric field at this point, we have q x is equal to r 4 pi epsilon naught r square plus radius is also r square 3 by 2. So we have df, a small force df. You see, df is proportional to dy. That df is equal to minus kx, k dx, small x. Then nature of the force will be restoring, because negative of displacement, and this is your constant. And this k is nothing but m omega square. So if from here with this equation you compare this with all these things, this equation with this equation, you can find the k, and k is equal to m omega square, and you can find omega thereafter very easily. So omega square is equal to k by m is omega square. So we have omega square is equal to 1 by 4 pi epsilon naught 2 root 2, I think, r cube divided by m q into q. This will be your omega square. Now you can find the time period. Omega is under root q by 4 pi epsilon naught 2 root 2 r cube by m. Okay, I skip one term. Okay, we have defined lambda, that is nothing but q by 2r. Just put here, you will get this expression. Now you can time here t barabar 2 pi by omega. This will be the answer. Well, I think I have done well. I can understand all these things. I'm just giving you the insight into the things that how electrostatic force, in electrostatic force, given charge distribution, element of charge distribution come from form SHM, and just you need to find, you are asked to need to find the simple harmonic motion SHM. Time period of SHM. Just you know the differentiation you develop, and just you can find it in very easy way. Now one more question is that this is inclined surface having alpha r. This is horizontal and this is inclined plane, and from this beta we have point B the coefficient of friction between the particle B and the slope is mu, and tan alpha is greater than mu. Okay, so for the particle to remain in equilibrium, what should be the greatest value of beta? Greatest value of beta. Just you need to find the greatest value of beta so that the particle of B can be in rest. Okay, so we have to just balance the forces, and you can also consider the friction force in the net resultant forces of all forces acting on this point B, and resultant force will be just in upward direction of resultant forces to balance the resultant forces. Okay, so I don't know the where friction force will act. Well, this is inclined plane, and along this inclined plane this is also going to be beta, and along the inclined plane we have mg sin alpha. This is the force. You know, this is inclined plane and this is angle alpha. So in downward direction we have force mg sin alpha. So this is okay. And I think I should rub this. Well, so we have these forces will be mg sin alpha and and this line is going to be very important. So I think this is point A and this is point B. And it will apply actually the electrostatic force because they must have a charge. Sorry, I haven't mentioned. Actually, have a charge, you can say. So electrostatic force will react in action and reaction pair. Now, suppose this, consider this line. Okay, so this will be along the inclined plane, mg sin alpha, and perpendicular to this line. Okay, we have force mg sin alpha into sin beta, and in this direction, okay, this will be balanced by the electrostatic force. But I don't know where is the friction force. Suppose this angle is theta, I don't know. Oh, there is the friction force. But this force should be balanced. If the point is in equilibrium, then this force should be balanced. So take it one component of friction, that is F sin theta. Well, then F sin theta friction force should be balanced by this force because particles is an equilibrium point. Now friction force, we have mg sin alpha, sin beta and sin theta. Well, what will be the maximum value of friction force? F max mu into normal, that is mg cos alpha. Friction force can write with inequality less than equal to mg cos alpha. So these things will be less than mu cos alpha. Mg sin alpha sin beta and sin theta is less than mu mg cos alpha. So you have to find this greatest value. You can use this inequality to find the greatest value of sin beta. So sin beta mg is going to vanish out. Is less than equal to mu static cos alpha by sin alpha is going to be cot alpha, and alpha is going to constant, and sin theta. So just this is constant, you can't do anything. But sin theta is variable. We have to decide the sin theta actually. But for greatest value, sin theta must have equal to 1. Then sin beta is equal to mu static coefficient friction cot alpha, and beta is equal to nothing but sin inverse mu s cot alpha. This is your greatest angle. Okay, beta, this is your greatest angle, sin inverse mu s cot alpha, so that particle can remain in equilibrium. And actually this is charged particle, so it is balanced in this direction, and one component should be balanced. Just my purpose is to find the beta, so I've just balanced this force. Well, I think this is your answer. let us do some another problem. We have, this is dome shape. This is fixed. Look at this. This is dome shape, and this is a disc. A small disc is gently put on the dome. This can slide. Okay, this is vertical line. This can slide and it can break the surface. Having transversed the angle theta, it can break the surface. It can have velocity v here. It breaks the surface at angle. It breaks the surface at angle. Theta is nothing but sine inverse 3/5. Okay, this point breaks the surface, and there is a uniform electric field in horizontal direction. Uniform electric field. Okay. Now find the ratio of force, two force here you see acting while it is in circular motion. Two force will act upon it. One is gravity and one is this electrostatic force. So can you find this ratio, mg/q? This is your question. Just to find this. How can you solve this? Okay. Look, the motion along the curve, we can use motion of circular motion, equation of circular motion, and work energy theorem. Because two forces are acting on it and it gains the velocity. So we will just define what is the work done by electrostatic force and gravity, and that is equal to change in kinetic energy. And at this point we can also write the equation of motion. We can develop two equations, and from this we can really find this. I think I can find from these two equations. So motion, say it is A and B. Okay, consider the mass of the disk. Mass of disk is equal to m. Well, this is A and B. So from motion of object from A to B, we can write what is happening here. When it is going to A to B, it is coming down this much, and it is traveling this horizontal distance. This is horizontal distance, and this is nothing but this r. So this will be r cos theta this much, and this amount vertical distance, it travels downward. This distance is responsible for work done in gravity. This is nothing but r into 1 minus cos theta, r minus r cos theta, and this is r sin theta. Well, so work done by gravity, what will be for gravity? This is work, and displacement plus cos theta plus. Now work done by electrostatic force into displacement, r sin theta, is nothing but change in kinetic energy. Initially it was 0. Well, we have, of course, sin theta is equal to 3/5. Then, of course, sin theta cos theta is equal to 4/5. We can use this mgr 1 minus 4/5. This will be equal to 1/5 plus QE R sine theta 3 by 5 is equal to half mv square. mg by 5 plus QE by 3 QE by 5, we have half mv square by r, because this is the centrifugal force, mv square divided by radius. So that's why I have put this in denominator to make physicality of these things. This is actually a force in centrifugal along this direction, radial direction. Well, so we have mg plus 3 QE barabar 5 by 2 mv square by r. Okay, now equation of circular motion. Huge equation of circular motion. I think I should rub this. So well, now from equation of circular motion, from A to B, now in this direction, this is also going to be theta and downward mg, so we have force in this direction mg cos theta, and here this is QE, so QE, this is theta, this is 90 degree, and this is 90 minus theta, so this will be theta and this will be 90 minus theta, and this will be theta, sorry, this will be 90 degree, this is 90 degree, this is theta, and this will be 90 degree minus theta. Okay, this line and this line is perpendicular to each other, and this is theta. In one line it makes 180 degree, so theta 90 and this will be 90 minus theta. So along this direction we have component of this force QE sine theta. So along these directions, we have property of circular motion along radial direction. We can balance the force and write the equation of motion, because there is acceleration v square by r, v square the velocity along this direction. So we can write the equation of motion as mv cos theta minus QE sine theta minus normal, because normal will act in this direction, barabar mv square by r. Now at this point B, n is equal to 0. Now we have mg into 4 by 5 minus QE into 3 by 5 barabar equal to mv square by 4. Now again 4 mg minus 3 QE barabar 5 mv square by r. Now divide the other equations. We have 5 by 2. So this equation second. So divide first and second. We have mg plus 3QE by 4 mg minus 3 QE is equal to half. Now solve this equation and you can find this ratio of the force, and this will be, I can write the answer, mg by QE is nothing but 9 by 2. Okay, I think this is going to be a good question. This is, Cartesian coordinate system y or x, and this is non-conducting ring. This is non-conducting ring of mass m and radius is r, and this charge lambda is charge per unit length. And this is surface is rough. It is placed in rough surface, and at t is equal to 0, time is equal to 0 in uniform, and I can give you the charge distribution, how the charge is distributed. Here, positive charge in this coordinate, and here, can tell you the negative charge. So positive and negative charge will create dipole. Okay, so we have uniform electric field, which is uniform, is switched on, and ring starts rolling because torque will act on it without sliding. Okay, start rolling without sliding. Determine the friction force acting on the ring. Determine the friction force acting on the ring. Also is direction. Also comment on the direction of the friction force. Well, we have torque due to this electric field, because when a dipole, this configuration, positive and negative charge displaced, will create dipole moment, system of dipole moment. Then it is placed in electric field, then torque will act on it. Well, torque will act on it, and you can find torque is nothing but, this P cross E. Well, this is positive charge and this is negative charge, so consider this a small angle theta. Here we have positive charge and small angle theta, and this is negative charges, and dq nothing but r d theta, and this will be also r lambda r d theta, but it is negative. So two charges here, this one dq and here minus dq, and distance between them is 2r, then dipole moment dp, okay, will be lambda r d theta lambda r d theta charge into distance into 2r. This distance will be 2r. Charge into distance is dipole moment. We know dipole moment is q into distance. So we have lambda r square 2 d theta, and just cross this. So we have electric torque due to electric field. We have 2 lambda r square cross product sine theta, sine theta into d theta, and electric field. So this is will be our torque. Okay, d tau, you can say this. And on integration, d tau, we will get the tau electric field. Since it starts rolling in this direction, then direction of the friction force, how can you decide? Look, here the force will be in this direction dF, and this portion, small negative portion dF. So net translational force is 0. Then how can you see this? But it will rotate in this direction. So this is center of mass. Who will move the center of mass in this direction? A heat, because it's rotating in this direction. That is the friction force, and friction force will be in this direction. Okay, this is the direction of the friction force in this direction. This is responsible for movement in this particular x direction. It is going to advance more. It is going motion in x direction. Then there should be a force, linear force F, and this is linear force. This is force, friction force, will make it move in particular direction, in direction of friction force. Now just integrate it. Sin theta, this is 0 to pi by 2, 2 lambda r square by e, 0 to pi by 2, sin theta and d theta. We know this integration is equal to 1, 2 lambda r square in. We have solved many times this value of this integration. You just evaluate it, you can find 1. So this is your electric torque. Now, force equation, use equation of force. Force equation F, this is friction force, is nothing but F m into A. A is acceleration of center of mass. This is the force equation. Now you can use torque equation. Torque equation. What is the torque equation? Write the torque equation. To write the torque equation, we have to take some point. We always write the torque equation about its center of mass, or about the instantaneous axis of rotation, about instantaneous center of rotation. But okay, this is instantaneous center of rotation. You can find the torque about this point. Okay. This is the torque due to electric field, and since friction force never assists in rotation, because this is resistance force, it can't help in gain energy. It always opposes to gain energy. It will try to lose your energy. So torque, this will be negative. You can't add because it can't happen. Okay, he will get the free energy. This can't happen. Additional torque due to friction. Okay, this will. I'm laughing. Okay, I can't write plus. Okay, you should write negative with some wisdom, using some wisdom. Okay, sometimes you can use reason and logic to write certain things. So now torque due to friction. This is the net torque, and net torque is I into alpha. So we have tau E minus Fr is equal to mr square into alpha. We need to find friction force, and this is equal to ma. And since it is making a pure rolling motion, so A is equal to R into alpha. This is constraint equation for pure rolling. Now third, we have electric force 2 lambda R square E minus friction force R. I can think of this a small portion mr alpha. So we have m alpha into R is equal to AR. So R you can cancel, because both right and left side of this equation has R. So we have 2 lambda RE friction force barabar MA, and MA is equal to also friction force. So we have friction force is nothing but R lambda E. So we have found the friction force. Okay. And look, this is electrostatics, but in G advanced, you just have to be so much calculative, and you should have a good aptitude to solve the problems. Okay. So this is a friction force, and you have found the direction. Okay, enough for today. In next classes, I will solve more good numerical problems. That may be benefit for you for IT advanced. Thank you.